So before we get started today, are there any questions over any of the assignments so far? And what we're doing today is going to be, not essentially, is a continuation of what we did yesterday. Now, we did have an assignment yesterday, but the ones we want to look at today, not so much the first two, are going to be dealing with extraneous solutions. So I want to do two more with solving, and then we'll start getting into some with extraneous solutions. Now, the ones with extraneous solutions and the ones that we did yesterday, the first two we're going to do today, aren't really any different. The only main difference is that one of the solutions or two of the solutions, or a certain number of the solutions that we get, are going to be considered extraneous. It means that we will get a value of x from our solving steps in the process that we go about solving, but will not work in the original problem. When we plug them back in, they don't work. If we remember back to, say, Pythagorean theorem with triangles, we would end up getting that the side squared is equal to, say, 144. We found out that the missing side, we can say C, was the square root of 144. Well, the square root of 144 is 12 or negative 12, because we take the square root of it. But we know for triangles, the length of a triangle has to be positive. So negative 12 in this case would be considered an extraneous solution. It is a number that we do get from solving, but does not work in the original context. So that's what our extraneous solutions are. So when we look at this problem here, if we're looking for extraneous solutions, we're really looking for values of x that will make the denominator be 0. Now there's two places, well, three places that this could be, our x plus 1, 2x, and 2x. And to see what's going to make them be 0, we can just set them equal to 0. Now we don't have to list 2x out twice because it's going to be the same value for both. Now to solve the x plus 1, what we're going to need to do is subtract 1 from both sides, telling us x is equal to negative 1. All right, so the one thing we know for sure is that x cannot be negative 1. So that's one of our restrictions. The other one, 2x equals 0, we could divide both sides by 2 or use the zero product property. Zero product property states whenever we have two things multiplied together to equal 0, one of them must be 0. But we can't do anything with the 2, so the x has to be 0. So these here are our two restrictions. So if we solve this here and get an x value of 0 or negative 1, we know it won't work. Okay. Now let's look at solving this here. Now the first thing we'll need to do in solving is finding the least common denominator, our LCD, or multiplying it by it. Now if we look at the first rational expression here, we know we'll need to multiply it by x plus 1. To get the denominator simplify out, we need to multiply it by x plus 1, because these here will cancel. Yes. And if we multiply it by one of them, we've got to multiply it by all of them. So the denominator of our first rational expression is completely simplified. If we look at the middle one, what do we need? 2x, because we know this 2x and 2x will cancel. But we'll also have to multiply it by the other two, yes? Well, wait a minute, the last one, the 2x and 2x will cancel as well, yes? So we don't need it more than once. We only needed the 2x once. And we'll see what we have left. In the first one, we have the 3x in the numerator. And it's being multiplied by 2x. We have the negative 5 times x plus 1 is equal to 3 times x plus 1. Questions? Now at this point here, we do need to distribute, and then we're going to simplify. So we can do 3x times 2x. 3 times 2 is going to be 6. X times x is x squared. Here we can distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. And lastly, we can distribute the 3 here. 3 times x is, and 3 times 1 is plus 3. On either side of this equation, we don't have any like terms. 6x squared minus 5x minus 5, there's no like terms there. 3x plus 3, there are no like terms. Now, since we do have an x squared, we have the 6x squared, we're going to need to get everything on the same side equal to 0. Now, the way that we go about doing this really doesn't matter, because I could move everything on the left side to the right, or we can move everything on the right to the left, depending on which way we want to do this. Personally, I would move everything from the right to the left, because we're only moving 2 things. Where if we go the other direction, we're moving 1, 2, 3, and the x squared term would be negative. So, what we can do first is subtract 3x from both sides, which will tell us that 6x squared minus 8x minus 5 is equal to 3. Then we can subtract 3 from both sides, telling us that 6x squared minus 8x minus 8 is equal to 0. Questions on this here so far? Now, to make it a little bit easier to work with, is there a greatest common factor between these 3 terms? There's not a variable, but there is a number that will go into all 3, yes? 2? 2 will go into 6, 8, and 8. If we do have a greatest common factor that is a number, it's going to make it a little bit easier to solve if we remove it. We divide it out. If it's a number, greatest common factor, we can divide it out of the entire equation. If it's a variable, we have to factor it out. Because 6x squared divided by 3, 6 divided by 2 is 3. And we have our x squared. Minus 8 divided by 2 is 4x. Minus is equal to 0. Because solving 3x squared minus 4x minus 4 is a lot easier than solving 6x squared minus 8x minus 8. Yes, this will indeed factor. So we'll have our 2 sets of parentheses with 3 spaces. Now, since the 4 is negative, our signs are opposite. We'll have 1 positive, 1 negative. Factors of 3x squared. Well, the x squared is going to be x and x. And the only factors of 3 are 1 and 3. So we just need to pick 1 to put the 3 in. I'm just going to put it in the first set. And then we'll look at the factors of 4. Factors of 4 are 1 and 4 or 2 and 2. 2 and 2. Now we can check this here. 3x times negative 2 would be negative 6x. 2 times x is going to be plus 2x, which gives us a middle term of negative 4x. Is that what we wanted? Yes. So these are the correct factors. And we do have 2 things multiplied together to equal 0, so one of them must be 0. So 3x plus 2 is 0, or x minus 2 is 0. And at this point, we just need to solve. Well, the x minus 2, we would just need to add 2 to both sides, telling us x is equal to 2. For the other one, we have a few more steps. First thing we would need to do is subtract 2 from both sides, telling us 3x is negative 2. But since x is not by itself, we also have to divide by 3, telling us x is negative 2/3. Are either one of these our restrictions? Because our restrictions were that x could not be negative 1 or 0. Since they're not the restrictions, those are our solutions. The other thing we could have done is checked to make sure that those did work. And we could do that on either calculator. On the graphing calculator, because our two solutions were negative 2/3 and 2. So we could use the store feature, negative 2 alpha thirds store x, and type it in as alpha y equals enter 3x over x plus 1 minus alpha y equals enter 5 over 2x. And we get a value of negative 9/4. Then we can do 3 alpha y equals enter over 2x. And we get the same value of negative 9/4. Now our other answer was 2. Yes. So we can do 2 store x. And go back up and reselect it. And when x is 2, we get 3/4. 3 over 2x. We get 3/4. We get the same value on either side, so it does work. Any questions on this so far? All right, let's look at the next one here. Now for this problem here, if we went straight into least common denominator, what we're multiplying each one of these by, it'd be very tempting to say that we want to multiply each one of them by x plus 1 and x squared minus 1. However, if one of the denominators is factorable, we do need to factor it. Because the x plus 1, our denominator of our first rational expression, is as simplified as it gets. We can't simplify x plus 1 any further. However, x squared minus 1 will factor. Now, what will it factor to? Y'all remember? Just two terms being subtracted is a difference of perfect squares. So what times itself is x squared? And what times itself is 1? 1. So x squared minus 1 actually factors to x plus 1 times x minus 1. It's a difference of perfect squares. So that helps us a little bit, because if we'd have multiplied everything by x plus 1 and x squared minus 1, we would have multiplied everything, this entire equation, by an extra x plus 1. Because how many times do we actually need it? 1. And if we used x plus 1 times x squared minus 1, really we were multiplying it by x plus 1 times x plus 1 times, we would have added it in an additional time, one more time than we needed. Now before we start solving, we do need to see what our restrictions are, because the two places where x could be 0 is x plus 1 and x minus 1. Those are the two spots where the denominator could be 0. And if we solve for these here, for the first one we would subtract 1, telling us if x is negative 1, it would make one of the denominators or more than one of the denominators 0. So x cannot be negative 1. We would do the same thing for the other side. We would add 1, telling us x cannot be positive 1. So if we have positive or negative 1 as a solution, it does not work. If we got x equals negative 1 as a solution, we would just cross it out. It would just be a value of x that does not work in the original problem. Now, we can go on and start solving. So one thing we know we'll need to multiply through by is x plus 1. I'm going to rewrite that. We're going to need to multiply all three by x plus 1, because in the first rational expression, the x plus 1 and x plus 1 would cancel. In the middle one, we would have the x plus 1 cancel with the x plus 1, and the 3 does not have a denominator, so nothing would simplify. Is there anything else we need to multiply through by? X minus 1. Because our middle term, the x minus 1 would cancel with the x minus 1. Now what that'll leave us with is, in the first one, we have our 4x plus 1, and it's going to be multiplied by our x minus 1. The middle one, our 12, which is going to be 12, because the x plus 1 and x minus 1 that we multiplied it with simplified out with its denominator. Plus 3 times, wait a minute, we're multiplying it by x plus 1 and x minus 1, yes? Where did we get both of those from? They're the factors of what? Factors of x squared minus 1, yes? So what should these multiply back to be? We can do that there. Because if we notice that two of the factors we're multiplying together came from something we already factored, might as well just replace it. Because we could have written it back out as x plus 1 times x minus 1, which would have given us x squared minus x plus x minus 1, which is just x squared minus 1, which we got from its factors. Does that make sense? Yes. And I'm all for, if we can do something simpler, might as well. Now at this point here, we do need to distribute. 4x times x is going to be 4x squared. 4x times negative 1 is negative 4x. 1 times x is going to be plus x, and 1 times negative 1 is negative 1, 12. And distribute the 3 times x squared is going to be 3x squared, and 3 times negative 1 is negative 3. Now we do have some like terms to combine. On the left-hand side, negative 4x plus x is going to be negative 3x minus 1. On the right-hand side, 12 minus 3 will simplify. 3x squared won't, so we'll have 3x squared. Then we'll do 12 minus 3 is plus 9. Now again, since we do have x squared on both sides, we'll need to get them on the same side. Now when I start doing this, moving it from left to right or right to left, which side has the bigger x squared term? The left side or the right side? Left, yes? And I really try to keep whatever variable has the biggest exponent positive. So I'm going to move everything to the left side. I'm going to move it first. 4x squared minus 3x squared is going to be x squared. Minus 3x minus 1 is equal to 9. It would have been nice if the x squared is canceled, because that's an easier problem to work with, because it would be considered linear, but it's not. So here, we still need to get it equal to 0. We would minus 9 from both sides, telling us that x squared minus 3x minus 10 is equal to 0. Yes, we can factor this here. Now, what's the number in front of x squared? 1, which means if it does factor, our solutions are going to be rational numbers. They're going to be integers. They're going to be whole numbers. They're not going to have decimals, yes? So another way we could do this is to graph it, if y'all remember graphing quadratics. So we'll type it in as x squared minus 3x minus 10 and hit graph. Because wherever it crosses the x-axis would be the solutions. Or we can go second table, and we can look for what values of x will make the y value be 0. And we should have 2 for quadratics, which are negative 2 and 5. Now, if we wanted to factor it, we could do that. 2 sets of parentheses equals 0. Since 10 is negative, our signs are opposite. Factors of x squared are going to be x and x. 2 and 5, positive 2, negative 5. Now, you're probably saying, well, the values of x that we found for graphing were negative 2 and 5. But again, at this point, since I have two things multiplied together equals 0, one of them must be 0. So x plus 2 is equal to 0. X minus 5 is 0. For x plus 2, we would subtract 2 from both sides, telling us x is negative 2. That does match. For the other one, we would add 5, telling us x is equal to 5. Any questions on this here? Negative 2 and 5, neither one of those were our restrictions because our restrictions were positive or negative 1. So that's it. Questions on this here? Any questions over anything we've done so far? Let's look at this one here. So again, we're going to need to simplify a little bit with the denominators, looking at this one here, because our middle one is x squared minus 9, yes? X squared minus 9 will factor. It's a difference of perfect squares. Now, finding the extraneous solutions might be helpful for this one here, because there's a chance that they might show up. Does anybody have an idea what the biggest giveaway is? Well, at the very top of the page. Solving an equation with an extraneous solution. We're going to have extraneous solutions. It kind of says it on the page. And for the test, I will have a spot that says check for extraneous solutions, kind of giving you a warning saying, hey, there might be extraneous solutions in here. Does that make sense? I'm going to give you a heads up on the test. So, now before we solve any of these here, or check for extraneous solutions, it is going to be helpful to factor any of the denominators if we can. So the only one here that factors is our x squared minus 9. Now luckily for us, it is a difference of perfect squares. So it'd be x and x, 3 and 3, and we would have plus and minus. Now looking at all three, there's only two ways that we could get 0 in the denominator. And that is if x plus 3 or x minus 3 is 0. If one of those two makes us have a value of 0, then it's not going to work. Because x minus 3, x minus 3, x plus 3, and x plus 3. Now on the one in the middle, we do have both, but since they're being multiplied together, one or the other would work. More. So we just need to solve these here, x plus 3 and x minus 3. So for the x minus 3, we would add 3 to both sides, telling us if x is equal to 3, we would have a denominator of 0, so it doesn't work. For the other one, we would minus 3, telling us x cannot be negative 3. So if we have positive or negative 3, that would be an extraneous solution, and it would not work. Any questions on extraneous solutions or anything we've done for this problem so far? Okay, now our next step is to multiply everything so that the denominators will simplify out. What is one thing we know we'll need to multiply by? X minus 3. So we'll apply it to all three and see what happens. Well, the first one here, this x minus 3 and this x minus 3 will cancel. The middle one, the x minus 3 and x minus 3 would cancel. And the last one does not, because x minus 3 and x plus 3 are not the same. Yes. Now for the first one, that one won't simplify, but the middle, the x plus 3 and x plus 3 will cancel. And then the last one, x plus 3 and x plus 3 will cancel. Now what we have left after doing that is we have 6 times x plus 3 is equal to 8x squared. Because 8x squared, everything that was multiplying with it simplified out, minus 4x times x minus 3. Any questions on this so far? Now for the first set of parentheses, we need to distribute the 6. 6 times x is 6x, plus 6 times 3 is 18, equals 8x squared. Negative 4x times x is going to be negative 4x squared. Negative 4x times negative 3 is going to be plus 12x. Now on the left-hand side, we don't have any like terms, but we do have some on the right. 8x squared minus 4x squared is going to be 4x squared plus 12x. Since we do have an x squared term, we do need to get this equal to 0. So we could move everything from the left to the right or everything from the right to the left. Either direction we move it, we'll still need to be moving two things, yes? X squared is on which side? On the right side, yes? Might as well move everything to it. So the first thing we can do is subtract 6x from both sides, which will tell us that 18 is equal to 4x squared plus 6x. Still not equal to 0, so we would subtract 18 from both sides, telling us 0 is equal to 4x squared plus 6x minus 18. Any questions on this so far? Now we could go on factor from here, but is there a greatest common factor between 4x squared, 6x, and 18? 2. If there is a numerical greatest common factor, a number, factor it out, divide it out. Numbers we can divide out when solving. If it's a variable, we have to factor it out. We can't just divide it out. 0 divided by 2 is 0. 4x squared divided by 2 is squared. 6x divided by 2 is 3x, and 18 divided by 2 is 9. Now we could solve this by graphing. We could plug this into the graphing calculator and have it graph it. However, we're most likely going to have at least one fractional answer, because what is the value of a? 2, yes? So that means, especially if we think back to what we've done already today, when we had a value of a greater than 1, we ended up having to divide by it as one of our solutions. So we'll probably get a fractional answer, and the other one might not be. So we'll get at least one, if not 2. So it's probably better to graph it, or not graph it, factor it, or quadratic formula. But this here we'll factor. We'll have 2 sets of parentheses. Since the 9 is negative, our signs are opposite. We have plus and minus. Factors of 2x squared, well, x squared is going to be x and x. And we can say 2 and 1. Factors of 9 are 1 and 9 or 3 and 3. 3 and 3. Let's go and check to make sure we do have the correct factors. 2x times negative 3 is negative 6x. 3 times x is plus 3x. Negative 6x plus 3x is negative 3x. Is that the middle term we wanted? Is it the correct number, though? Okay. Which means we just switch the signs. And luckily, the only one we really need the eraser for is the plus, because it's quite easy to turn a minus into a plus. So we have these two here. Since we do have two things multiplied together to equal 0, one of them must be 0. Either 2x minus 3 is 0, or x plus 3 is 0. For the 2x minus 3, first thing we can do is Add 3 to both sides. Telling us that 2x is equal to 3. From here, we can divide both sides by 2, telling us x is 3/2. There's one of our solutions. On the other one, we can minus 3 from both sides, telling us x is -3. Do both of these solutions work? Yes. That is an extraneous solution. We can cross it out. And again, extraneous solutions are solutions that work, we actually get by solving, but do not work in the original problem. It would have thrown up an error, yes. So we can do the same thing we did on the first one, plugging it in for it. I'll show you the other way we can check it. So 6 over -3 minus 3. So this is the one side. It's -1. Now if we look at the other side, we have 8 times -3 squared over -3 squared minus 9. Minus, right, 4 times -3 over -3 plus 3. If I hit enter, division of 0. Doesn't work. Because if we looked at this by hand, 6 over -3 minus 3 times -3 squared, -3 squared minus 9. Well, the left-hand side works out kind of nicely because -3 minus 3 is -6. -3 squared is 9, same as the denominator. -12, well here, -3 plus 3 is 0. That's a division of 0. That does not work. Well, -9 minus 9 is 0. That's a division of 0. That doesn't work. So -3 doesn't work. In the process of solving, it does, and it's coming from our x squared, the fact that a negative squared can be positive, negative. We have some of those that come into play. It doesn't work. So our only solution is our three-halves. Any questions on this here? So